Welcome to today's lecture at Minds of Machine. We're diving into part 2 of the neural network tutorial, in which we are focusing on building multiple neural networks and exploring 2 distinct methods to enhance your machine learning projects. NumPy is a powerful library in Python that provides support for large, multidimensional arrays and matrices, along with a large collection of high-level mathematical functions to operate on these arrays. In the context of neural networks, NumPy is crucial for handling operations on large datasets and weights across multiple layers efficiently, facilitating the building and training of complex, multi-layer neural networks with speed and ease. Let's get started.
Now let's understand the code. So first we will import the NumPy library to handle the operations on large multidimensional arrays and matrices. And it is essential for performing numerical operation, particularly useful for operations on arrays, matrices, which are fundamental in neural network computation. Next, we will define the input, a list of lists where each sublist represents a single set of inputs to the neural network, and each input vector here has 4 features corresponding to the neuron's weight in the following layer. So we will define a list of input vectors, each with 4 features, as you can see. 1, 2, 3, 2.5 can be considered as the feature. Next, we will define the first layer weight, in which the weight represents the weight connecting to the input layer to the first hidden layer, and each sublist corresponding to the weight for one neuron in that layer. In this, the weight is associated with the first layer of neuron, and each sublist represents weight for one neuron. I'm just adding command of to show the input of a picture or any object which you think is this, which we pass to the neural network, is converted into numerical format. Same way, adding the comments over here to identify that this is the weight for the first layer. Once that is done, next we are going to define the first layer of biases, a list of biases, one for each neuron in the first layer. This biases helps the model adjust the output along with the weighted sum of the inputs. So this is the biases of the first layer of neuron, and one for each neuron. As you can see, it is defined as 2, 3, 0.5. Now let's define the weight for the second layer. Weights are connecting the first hidden layer to the second hidden layer, structured similarly to the first layer. Weight for a second layer of neuron is structured similarly to the first layer's weight. As you can see here, we have given a different weight, 0.1 minus 0.14, 0.5. So it's in the similar structure format. Now, once the weight is defined, we will now define the second layer biases. Biases for each neuron in the second hidden layer is defined now. As you can see, it is defined as biases 2, in which we will define the value as -1, 2 and -0.5. Now, once that is done, we will do first layer's output calculation using the np dot function to compute the dot product of the input and the transpose of W1, aligning to the dimension for matrix multiplication. As you can see, in the first we have defined 4 features, in the second we have defined 3 features. So then we add the biases, and the output is the activated result for the first layer's neuron. To calculate the output of first layer, we basically do is dot product of the input and transport W1 matrix, add the basis element wise. So you can see layer 1 output is equals to np dot bracket input, np dot array dot t is the transverse function, and then we do is input. Then we add as the biases. Now we will calculate the second layer similar way by computing the output of the second layer similarly by taking the dot product of the first layer output with the transpose of W2 and adding the second layer biases. So as you can see in the code, its layer 2 output is equals to np dot layer 1 output comma np dot arrays w2 dot t bracket, and then it gives the byproduct plus biases. Now we will print the final output of the second layer, which is the in real application could be the input to yet another layer or the final output of a simpler neural network. So we are printing the layer 2 output. So in this way, the multi-layer neural network's basic structure is and how it is defined and built in code. I'm just adding the comment so that it can give a better visual representation to you all people. So yeah, this is how you can create a multi-layer neural network. Now let's see how the output looks. So here you can see the output of the neural network 2 when it is multiplied with the layer 1. I mean the layer 2 output, which is when multiplied with the layer 1, and this is how our final output look when we have a multi-layer neural network. This code represents a basic feed forward operation in a neural network with two layers using hard-coded weights and biases in practical applications. Weights and biases are optimized during a training phase using learning algorithms like backpropagations. Now let's implement the same hidden layer neural network or a multi-layer neural network in different way. So first we will do the same thing, that is import the NumPy library, a fundamental package for scientific computations with Python. Next, we will set the seed for the NumPy's random number generator to ensure reproducibility of the randomness in the code. After that, we will define a list of X containing input data for the neural network in the form of list of lists. Next, we will define a class called as layer dense to create a dense, fully connected layer in a neural network, in which we will construct for the layer dense class with the by initializing each layer by defining init function, and then the shape of the matrix is n input, n neurons, where n input is the number of inputs and input features, and n neuron is the number of neurons in the layers. Then we define the self weight, which is equivalent to 0.10 into 10 into n random dot random bracket n input multiplied by n neuron. This is how we define the shape of the matrix. Then we initialize the base as 1 into n matrix, that is row vector of zeros, where n is the number of neurons and each neuron has a single bias term. Next, we define a method called forward, which performs the forward pass through this layer using given inputs. After defining that, we will calculate the output of the current layer by applying the dot product of the input and the weight, then adding the bias, and this is the basic computation performed by a neuron in a dense layer. Now we instantiate an object layer 1 from the layer dense class specifying 4 input features and 5 neurons. So basically we are trying to do it in a very more dynamic way. Initial was a simpler way of doing it. This is more of a dynamic way. And then now we will initiate another object layer 2 from the layer dense class specifying 5 input features and output of layer 1 basically and 2 neurons. Then we perform the forward pass through layer 1 using the input data x. Then we print the output from the layer 1 which serves as an input to the next layer as print layer 1 dot output. Then we perform the forward pass through layer 2 using the output from the layer 1 and finally print the output from layer 2 which is final output of the neural network after 2 layers. As you can see here, now we are displaying the first layer of neural network, how it is seen by doing the basic computation, and this first layer act as an input of the second layer, and this is how the second layer output looks like. So this is how the data flows through a simple 2-layer neural network using dense layers where each neuron output is computed as weight, sum of the inputs plus a bias term. And this is the foundation concept in building a multi-layer neural network. So this is the basic, this is how you can build your basic layer neural network and then train it. So for now, the part 2 of the neural network course is done. So I'm signing this off. Hope you have learned amazing way of building a neural network and you build of your own, and let me know how you felt after building it. Thank you for watching our tutorial. So this is Aishwarya, the founder of Minds of Machine. Thank you for watching. Bye bye. See you for the next tutorial.